Hello, folks. So, welcome to part 10 of Learning Rust from Scratch. And in this video, we're going to actually continue and look at the second chapter's last part, which is handling invalid input, which is if you type something other than the expected type of input. Um, for example, the program is looking for a number, but then if you give a some random string which does not contain a number, then you know, give an error and maybe let them retry. So to further refine the game's behavior rather than crashing the program when the user inputs a non-number, which is crashing as in panicking. So let's make the game ignore a number or non-number. So the user can continue guessing. We can do that by altering the line where guess is converted from string to unsigned third bit. So this is the place we parse it. Here, instead of saying expect, what expect does is basically does this only. We're just going to copy this up and remove this and say, so we have OK and what is this? Why does this give an error? So expected this found result unknown unsigned third bit parse OK number. It's fine, no TP should be fine. Why is there an error? Expected semicolon. I think it's probably because of this. I'll probably put this as continue and say this. I'm not sure what's the error here. Um, Ordering is not needed. Okay, sure. Something's gone wrong. Let the guess match. Oh, we have to match it. Sorry. So we have to match this. Yep. And then no. Yeah. I shouldn't just put a thing. And I think there should be a semicolon here. Yep. And yep, for ordering, we do need that. Oops. Use std. I think it was, forgot this was from, I think CMP ordering. Yeah. So, oh, hey, so now it shouldn't be a problem. Instead of t, we can just call this as number or num. So if it is I mean, if it's okay, then capture the value number and give it back. If it's error, actually we can do something extra here. We can say pass int error and we can actually close this out and we can say print line. So something like there was an error understanding the input. Seems like the input is not a number. Um, verbose error is this, and you can just mention err. And why is there an error here? Expected semicolon, found keyword, good, okay. Okay, I think we should be good now. But if we don't mention this, it'll be weird. Like, oops. Like, let's say we don't mention this and If this is intentional, prefix it with an underscore, or you can actually say just underscore. So cargo run, let's say I type blah. It just says please input your guess, that's all. Right? So instead we can actually say um, underscore error. Actually just make it as error. And let's say SA16 given. Okay, so if I say blah, it says there was an error. Understanding the input seems like the input is not a number. Uh, verbose error. Invalid digit found in string. Okay, so we just say 35 and let it go. Right. So now this looks nice. And so we've handled the invalid input. So we switch from an expect call to a match expression to move from crashing on an error to handling the error. So we handle the error instead of crashing on the error. Remember that parse returns a result type, and the result is an enum that has variance OK and error. And so those are the only two possibilities. We are using a match expression here as we did with ordering result of the CMP method. So basically with match, you can basically use different possibilities. There's a match value, and then there are different expressions in the match. Um, Different arms. Each arm has an expression and then a code to execute if the expression and the value and match expression match. Um, so we are using a match expression here as we did with ordering result of this CMP compare method. If parse is able to successfully turn the string into a number, it will return an OK value that contains the resultant number. That OK value will match the first arm's pattern, and so there's a pattern in every arm, and the match expression will just return the norm value that the parser produced and put it inside the OK value. That number will end up right where we want it in the new guess variable we are creating. If pass is not able to turn the string into a number, it will return an error value that contains more information about the error. The error value does not match the OK number pattern in the first match arm, but it does match the um, you know the error thing matches the error pattern in the second arm, and the underscore is a catch-all value. In this example, we're saying we want to match all errors, all error values, no matter what information they have inside them. So the program will execute the second arm's code, continue, which tells the program to go to the next iteration of the loop. So continue the loop and ask for another guess. Uh, So next iteration or the next time of the loop. So effectively, the program ignores all errors that pass might encounter. Now, everything in the program should work as expected. And yeah, awesome. With one tiny final tweak, we'll finish the guessing game. Recall that the program is still printing the secret number. Yeah, we shouldn't print the secret number. That worked well for testing, but it ruins the game. Let's delete the print line that outputs the secret number. Shows the final code. So the secret number is this. And at this point, you've successfully built the guessing game. Congratulations. Okay. So we cannot. So this secret number, oh, no, it's being used later for the compile, but other than that, it's not being used anywhere else. So if we just run and we input a guess, let's say 10, too small, okay. How about 20, too small. How about 30, too small. 40, too small. 50, too small. 60, too big. Oh, between 50 and 60. 55, too big. 50 and 55. 52, you win. Awesome. This is the number guessing game. This project was a hands-on way to introduce you to many new Rust concepts, let, match expression, functions, the use of external crates, and more. In the next few chapters, we also had enums, enumerations. In the next few chapters, you'll learn about these concepts in more detail. Chapter 3 covers concepts that most programming languages have, such as variables, data types, and functions, and shows how to use them in Rust. So, Chapter 4 explores ownership, a feature that makes Rust different from other languages. Chapter 5 discusses structs and method syntax, and Chapter 6 explains how enums work. Cool. So, I will see you in the next one. And that's all I have for this video. See you on the next one. Bye.